On most farms, you have bits of metal tube, an angle grinder, and that's all you need to do your density measurements. So what we do is we push our corer into the clamp, we remove the silage in the core, we measure the depth of the hole, the radius, which is half the diameter of the corer, and we weigh the silage that we remove from the hole on a standard balance. And then we can calculate the density because it is weight over volume. Volume is the volume of a cylinder, which just so happens to be pi multiplied by the radius squared multiplied by the depth. That's the radius of the corer, the depth of the hole. The weight we should measure in kilograms and the volume in meters, and this just makes the calculation easier because we want a value in kilograms per meter cubed. So once we've done that, we can calculate the density in different points, and I would suggest you do it in at least 3 different places, but preferably also maybe near the walls as well, to look at the variation in density. And there is always variation. So on today's clamp, I've measured the density in 3 places: top, middle and bottom. The density at the top was 366, in the middle it was 383, and in the bottom it was 595. That's all kilograms of fresh matter per metre cubed. Because this is a whole crop silage, it's relatively dry, so I've estimated that it's around 45% dry matter. So whilst our densities aren't very high, because it's on a fresh matter basis and it's almost 50% dry matter, they are pretty good. The reason why the base of the clamp is much denser is twofold. We've had some settling during time, and secondly, it is actually wetter because the moisture in that crop has gravitated to the bottom of the silage during this time. So on a dry matter basis, it won't be so different. But what's very impressive in today's clamp is that the top I said was 366, and in the middle it was 383. So the difference between those two is very, very small. And in fact, the top is a little bit drier than the middle. So on a dry matter basis, I would expect them to be the same. On many clamps, we have a big difference between the top and the middle. And that's because we haven't kept enough density as we've gone up the clamp by consolidating properly, and we haven't kept the weight on the top of the clamp. So this shows that we can have more even density throughout the clamp. I would also be doing this at the walls because the walls are a particularly weak point, so within ½ metre of the wall. And that is somewhere that is more difficult to consolidate, but it's also where we have that more risk of oxygen penetrating because of our lack of sheeting on many clamps, or even when we have good sheeting, there's more risk of damage. So it's important that we get that good density right across the clamp. I've just shown how to measure density, and I would like more and more farmers to actually pay attention to this, because compaction density is key to reducing significantly your losses. If we get more silage within a given volume, we have less ability for oxygen to be retained in the clamp, and when we open it, less ability for oxygen to push further back into the clamp. And this improves our quality and reduces the risk of aerobic spoilage, which is the heating of the silage at feed out. It also means that if we have some accidental damage to the sheet after it's been applied correctly, that oxygen will penetrate less deep into our silage clamp, causing issues.